Statistics is a discipline that allows people to make decisions from data. So statisticians focus on, first of all, formulating questions that are of interest and then saying what's the best way of answering that question using data. So that might be designing experiments, that might be looking at existing database and mining those databases for nuggets of information or using observational studies. But the idea is to use data then to make decisions in the face of uncertainty. So our bachelors in statistics, every major chooses one of three emphases. The first one we call statistical science. And if that sounds sort of like regular statistics, that's kind of what it is. It's a little bit more theoretical. You're going to have a little bit more mathematical training. And the main emphasis there is to prepare people for a graduate program in statistics. So a master's or a PhD, you're going to want to study statistical science. Biostatistics is a second emphasis. The biostatistics emphasis helps people prepare to focus specifically in potential future graduate study in a biostatistical or biological field. Also, a lot of people use the biostat emphasis as a nice major to go with pre-med or pre-dent, because you can use a lot of those classes you're going to be taking anyway as part of that program. So you can make that efficient. The third major then is one that's really geared more towards someone who's not going to go on and get another degree. So it's really designed to be a terminal bachelor's degree, and it's applied statistics and analytics. And here we're going to focus a little bit less on math, a little bit less on theory, and a bit more on just very practical skills of data analysis and analytics. A little bit of programming, not at a deep level like a computer scientist would, but just a little bit more kind of a pragmatic, get you up and running sort of degree. So that's actually the most common of our emphases. The most popular is that applied statistics and analytics for students that just want to get that bachelor's and start doing analytics. Our graduates head into a really wide variety of jobs. Sometimes the job title is statistician, where they're actually working with data coming in and analyzing, making decisions, making comparisons. Other times our graduates are getting jobs like quality engineer or analyst or modeler. So a lot of our majors have been getting jobs in the business industry, a lot in banking and finance, in technology, so in places like Intel or Microsoft, or anywhere there's people doing experiments, they're gathering data, trying to make decisions, improve products, there's going to be statisticians on board. So we also have a lot of statisticians that work in government, so the Bureau of the Census, Bureau of Labor Statistics. So we have people working in really jobs across all of the employment sectors. So the skills that you're going to be developing as a stat major involve how do you get to that point where you can make decisions from data. So we're going to start with taking a question or a hypothesis or some sort of issue that needs to be addressed and turn that into a data-based issue. So what kind of data am I going to gather and how am I going to gather that? In this new modern era, in the data science era, where data is so ubiquitous, so easily available, often that's going to a sort of non-standard data source. So it might be a data source like every one of Amazon's pages, right? So that doesn't sound like a traditional data set, but statisticians are now doing things like data manipulation or data munging, sometimes we'll call it, to turn these sorts of non-traditional data sources into data that we can use to make decisions. So how do you manipulate data? How do you take data of a non-standard form and turn it into a form you can actually make decisions from? And then a lot of modeling and prediction. So by modeling, we mean how do you describe numerically some phenomenon you're interested in? Maybe it's how much some product is going to be selling, over the next year. So we might build a mathematical or statistical model for describing what that might look like, and we'll use that model then to make predictions going forward. Pretty much any of the sciences are going to be dealing with data. What makes statistics different from, say, a biologist or a chemist is that we're focused specifically on turning data into decisions. Mathematicians also play in this space, but mathematicians are fundamentally focused on really kind of core fundamentals. So statisticians are going to be using mathematics and probability to make decisions, but we're really focused on the data, not on the underlying mathematics, right? What is the data telling us? Computer science is another related discipline, and computer scientists often play in the same space. They're doing predictive modeling, but a computer scientist is going to be focused more on programming. There's going to be a great deal of computer programming, and we tend to maybe a little less low-level programming, and we use high-level programming languages to answer the questions that we want to. So we're really focused on data as opposed to fundamental tools or programming. Well, statistics is actually a pretty fast-growing major, not just at BYU, but around the country. Particularly undergraduate degrees in statistics are going up exponentially. Here at BYU, our major has quadrupled in the last 10 years, the number of majors. So why is that? It's a really marketable career. So every year, careercast.com lists its top 10 jobs based on career satisfaction and potential for growth and salary and working environment. Every year, statistics is in the top 5, right? This last year, statistics was number 1, and a related area, data scientist, was number 2. So these are areas where there's just a great deal of demand. The Bureau of Labor Statistics said that over the next 10 years, we expect a nearly 200,000 person shortage in statistics. So if you're looking for a career that has good job prospects, this is really a great time to be a statistician.